For series circuits, there is only one path for charge flow. For parallel circuits, there are multiple charge flow paths. So the current, or the arrow tails, or the amps, split at some points, namely this junction right here, where 3 arrow tails split into 2 and 1, and then those currents come back together at other points. There are different equations for finding the equivalent resistance for series and for parallel, so we must use the proper equation for a given portion of a combination circuit. So let's try this combination circuit problem. We've said before that Ohm's law must hold for any row in this table. So if we know 2 of the 3 values, we can use Ohm's law to find the third. It's quite easily found that there must be 1.34 amps of current going through resistor 1 and 0.41 amps of current going through resistor 5. And that's because delta V is equal to I times R. Now, since we have the schematic diagram and we have all of the resistances of the individual resistors, let's go ahead and find the equivalent resistance, which is the resistance perceived by the battery. See, as far as the battery is concerned, there's only one resistor in the circuit, and let's try and figure out what that resistance is, assuming there's only one resistor in the circuit. So we're going to take this portion of the circuit. These 2 resistors are in parallel. If we were to tear them out and replace them with a single resistor without the battery knowing any difference, what resistance would that one resistor have? Well, we would need to take 1 over 6.5 plus 1 over 8.5, add those up, and take the reciprocal. That comes out to be 3.68 ohms. Let's do the same thing with resistors 3 through 5. Those are also in parallel. Let's imagine tearing those 3 out and putting one resistor in their place such that the battery wouldn't know any different. So again, because these are in parallel, we'll use the 1 over relation. So we need to go 1 over 4.2 plus 1 over 4.8 plus 1 over 10.6, add that up, and take the reciprocal, 1.85 ohms. We'll do that one more time with resistors 7 and 8, which are also in parallel. 1 over 5.7 plus 1 over 3.8, add it up, and take the reciprocal, 2.28 ohms. Those 4 resistors, 3 of which are imaginary, resistor 6 being the only one that is actually there, those 4 resistors are in series. So if we simply add those resistances up, that would be the resistance that is perceived by the battery, 15.31 ohms. So we'll put that in the upper right box of the table. Now we can find the current going through the battery to be 2.35 amps. What to do next? It doesn't really matter. Why don't we start color coding wires with voltages? This is a 36 volt battery, so the upper left portion of this circuit I'm going to give the color 36 volts, and this lower left portion of the circuit I'm going to give the color 0 volts. Now, according to the table, we're told that resistor 1 has a voltage difference of 8.7 from one side of it to the other, which means that the color of the upper right portion of this circuit, all of these wires here, the color of that, or the pressure of that, is 27.3 volts. Now we can find the pressure difference across resistor 2. It's also 8.7, and we can then find the current going through resistor 2 by Ohm's law. 8.7 equals what times 8.5 to be 1.02. Notice that the sum of these 2 currents is very nearly equal to the current that's going through the battery. If we have 2.35 amps going through the battery, right here, the current has to split. Some goes through resistor 1, some through resistor 2, and those should pretty much add up to be 2.35. There's a little bit of rounding error, but we're not going to worry too much about that. Now we can see that if the upper right portion of this circuit has a color or an electric pressure of 27.3 volts, and we're told in the table that the pressure difference across resistor 5 is 4.3, that must mean that the color of this trident-shaped series of wires must be 23 volts. And therefore, the pressure difference or the color difference across resistors 3 and 4 is also 4.3 volts. So now let's find the currents going through those resistors using Ohm's law. Note here, again, that the sum of these three comes out to be 2.33. Again, we have a little bit of rounding error, but where the current going through the battery has split right here through resistors 1 and 2, then that current comes back together right here, and then it splits three ways, as we see in the table. Okay, now that 2.35 amps is all back together again, and it all must go through resistor 6. So we can find the pressure difference or the voltage difference across resistor 6, which means that the color of this lower right portion of the circuit in terms of electric pressure must be 5.37 volts. 23 volts on one side of resistor 6 and 5.37 volts on the other, which would give a difference of 17.63 volts. The pressure difference across resistors 7 and 8 must both be 5.37 volts, and then the currents through those resistors can very easily be found, and we're done.